Okay, how you doing? We're going to talk about graphing some inequalities and solving these inequalities. So the first thing that I have here is what we have, just a regular inequality, and this is what we would consider the introductory start to them, where I have this expression of 6x minus 5, and whatever I plug in for this value of x, it must be less than or equal to the number 7. So much like before, what we would do is if we had an equation, so let's say I had an equal sign here instead, I would be finding the x value that would be equivalent to that 7. And when you do that, the important thing to talk about here is that if I were to solve this like it were an equal sign, like an equation, and this particular one, let's talk about what it is that I would get, okay? So the first things first, I have the negative 5, so let's add 5 to both sides. Add 5 to both sides. And what I'm left with is that 6x, and I bring this inequality down. Remember, I'm just thinking of it as if it were an equation. So less than or equal to, and in this case it's 12, okay? When I do that, I end up finding that this x, when I divide by 6, I get x is less than or equal to the number 2. Now, if this were an equation, what I would be saying to you is that if I plug in a 2 up here and subtract 5 from it, so 6 times 2 minus 5, it does give you 7. But let's check some other things out. Because in inequality, there's basically two types. You have the less than, or you have the greater than. So what I want to check here is that, okay, well we have a 2. So we have this number 2, okay? And if I talk about it in the sense of a number line, then I have this number, and here's 0, here's 1, and here's 2. The number 2 on a number line, if I were to plot this point, is right here. Okay? So I go ahead and I plot that point. Alright? Now, what we need to talk about here is that I have this expression that I want to be less than the number 7. When I go through and find this x, what I'm finding is the value that I can plug into this expression that makes a number less than 7. Not necessarily talking about all numbers less than 7. It's literally just talking about what is the number that I can plug in for this x. So what is the solution that I can plug in that would make this a true statement. Now, this number 2, what we need to realize is that there are infinite amount of numbers less than 7. Because if you tell me one number, I can tell you another. For instance, if you tell me 5, I can say, okay, 4.9. Well, 4.9 is less than 5, which is also less than 7. So, for these answers, we can't just come up here and say, okay, this is what we would call the abstract reasoning to it. But if I want to graph it, the graph is literally just going to be the picture of the diagram of all the numbers that would work. So if I pick a number in any of my shaded region that we usually use, that means that that number that I picked in that shaded region will also make this expression true. So what I want to check here is that this number 2 is going to be like my indicator, okay? And the indicator, what I mean by that is that I have numbers that I can pick that are either going to be to the right of 2, or I have numbers that I can pick that are to the left of 2. So picking any number in the world that I want, it doesn't matter, okay? But if I pick a number to the left of 2, that is like a number 1, okay? So 1. If I pick anything to the right of 2, like 2, 3, 4, 5, 6, I can continue to go that way. And what I'm going to try to do is pick up on a trend of numbers that will seem to be working. And in this case, I have 6x minus 5. So I come up here and I go, okay, x is less than or equal to 2. So this expression here is saying to me, algebraically, any number less than 2 will also make this expression up here less than 7. So let's go ahead and just plug some numbers in to prove this. Because let's say we have trouble reading this and going, oh, what numbers make this work? So what you need to always think about is that no matter what number you find here, no matter what number, if it's on the left side or the right side, is irrelevant. When you come back up to this number line, you just check numbers to the left of it and you check a number to the right of it. And you plug that thing back into this original expression. So, checking to see what numbers of patterns are going to be where my shading is going to go towards. Is it going to be to the right of my point, or is it going to be to the left of my point? Because once I find one point that works, then all points to the left work, or all points to the right work. So, let's check out the number 3. So let's plug in 3 first. So into my original equation, what I'm going to do is that I'm going to check, is this true? At the end, do I create something that is actually true? So 6, so here we go, 6 times 3 minus 5. Is that expression actually less than, or it could be equal to, 7? Well, 6 times 3 is 18. 18 minus 5 is 13. Is 13 actually less than 7? Well, no, it's not. So since this number here is not, okay, less than the 7, it's not a true statement. And if it's not a true statement, what it means is that if I picked any other numbers over here, they would not work either. And the way that we're going to show our solutions is by shading along the number line to say, hey, these numbers will work, plugging it into here. So let's pick a number left of 2. And a number left of 2, okay, I can pick 1, I can pick 0, I can pick -1, -2, -3. Doesn't matter. So if I'm, in this case, if I can pick 0, whenever I can pick 0, I always pick 0 because it's going to make everything so much easier. So let's try 0. So 6, plugging 0 in for x, minusing 5 from it, is it going to give me a value less than or equal to 7? And if it does, what I need to note here is that the number to the left of 0, or 2, sorry, is going to also work. And we'll prove that again with another one. So 6 times 0 is 0. 0 minus 5 is -5. Well, is -5 in this case, is that less than or equal to 7? Well, yes, it is. So what I've actually found is another number that is going to work that I plug in here will make a true statement. And remember, when you're looking for a solution, you're looking for all the possible numbers that make a true statement. -5 less than 7 is a true statement because -5 actually is less than 7. So just to prove this idea, okay, that any number to the left of my indicated value that I solved for will work, okay? We could pick 1, but let's pick a number like a crazy number. Let's pick like -15, okay? Well, 6 times -15. And then -5 from that, is it going to give you a number smaller than 7? And that's all I want to check for. And if it does, then obviously we're just proving that this fact is that anything to the left of my point that I solved for over here, okay, is also going to work. So 6 times -15. 6 times 5 is 30. 6 times 10 is 60. So this is going to be -90. -5, is that going to be less than 7? Well, any negative number is smaller than a positive. So this is -95. Is -95 less than 7? And if so, then it's true. In this case, it's true. So what we're going to show here is that we shade the number line depending on the side that makes my answers true. And once I find one to be false, believe me, all the other ones to the right or to the left of the number, whichever ones you find to be false, are all also going to be false. So that was just going through and solving this, and going through and just talking about the thing. Now, I do want to talk a little bit more, okay, because this is just solving and plugging it in to find the solution. Let's talk more about what are some things that change values or change signs in mathematics. And one of the things that changes a sign in mathematics is a negative. So what happens if I introduce a negative into the problem, okay, and the only way you change a sign through always, and I say the word always because the word always is important, that if I add a negative to a number, does it always make it negative? Like, for instance, if I took 5 and added to it -2, is my answer always negative? Well, to prove that in this case, okay, this does not change the sign of the original number, okay? And what I mean by that is it changes the value, but it doesn't change the sign. So 5 plus -2 is 3. So 5 and 3 are both positive, so it doesn't change the sign. So the adding doesn't work. Well, if I subtract, adding and subtracting are the inverse operations of each other, so they're going to hold the same property to be true. But if I take a number, okay, so say I have 5 and I multiply it by -3, does multiplication always change the sign of the original to a new sign? Well, in this case it does, because a positive times a negative is always going to be negative. So that makes this original thing here was positive, it changes it to negative. So the output here is -15. So 5 and -15 are opposite signs. Okay, that opposite sign is a key word. So also, if it were negative, right, and I times it by another negative, so negative 3, the original number is negative, but when I multiply them, I get a positive. So again, opposite signs, and that's an important thing to carry on with you. So, how does that carry over? And multiplication, its inverse operation is division, so it holds the same property, okay? So why is that important? Well, let's talk about this. Let's say I have x divided by negative 3 plus 2, and I say that that is less than or equal to 1. So what I'm trying to find is a number that I can plug into x, okay, that is going to be less, divided by negative 3 plus 2, this expression, which will give me an answer less than 1. So, here we go. Now that I take a look at this, all right, I come up here and I go, let's solve it like we normally would as if it were an equation. Like if I'm going to find what's the actual number that makes it equal to 1. So first things first, we subtract 2. Subtract 2. I'm left with the expression of x divided by negative 3 is less than or equal to negative 1. Now, at this point, what I'm going to go ahead and do is I'm going to multiply by a negative 3. Now, that negative 3, remember, changes your signs to the opposite, so the opposite signs. So this negative 3 that I'm going to multiply by, okay, and I'm putting it in parentheses, if this negative 3 is, whatever I do, the notation that I like to use is always to put the thing that I'm multiplying in by the parentheses. So, I'm multiplying by the negative 3. I'm multiplying by the negative 3. This is the number that's going to change the sign of this. So what I get left with over here is that these negative 3's reduced to 1. I'm left with 1x. And the important thing now to have happen here is that a negative was introduced into the number line to talk about the opposite direction of your values. So, opposite direction is important because this symbol right here tells you on a number line if it's less than, you're obviously to the left of any number. If it's greater than, you're to the right of any number. So right now this expression is less than. So this negative is saying to you, take the opposite sign of everything. And an inequality is a mathematical sign. So I can take the opposite of it. So instead of being a less than, I turn it into a greater than or equal to. And that all has to do with that negative multiplication or division that I've done. In this case, I multiplied by a negative. Negative 1 times negative 3, change that to being a positive 3. So what this expression says is x is greater than or equal to 3. So again, I go to my number line. All right, and I plot my point. So here's 0, here's 1, here's 2, here's 3. So I plot my point 3. Okay? And there's two indicators you have for inequalities. You have the greater than or equal to, or you have the greater than or less than or equal to. If it's equal to, we shade our circle in. If not, we leave it open. So in this case, it's equal to, so I shade underneath. And I can read this explicitly and say any number, so this x is any other number greater than 3 will also make this statement true. So numbers that are greater than are always to the right of another number, so I shade to the right. Now let's say you have trouble memorizing that. Pick a number, any number. Pick a number to the left of 3, pick a number to the right of 3. You pick 2, if you plot, well, let's pick negative 3. We'll pick a number all the way to the left. Remember I said if you can pick 0, always pick 0. So the number to the left of 3 is 0. What is 0 divided by negative 3? Well, that's 0. 0 divided by anything is 0. 0 plus 2 is 2. Is 2 less than 1? Well, 2 is not less than 1. So since 2 is not less than 1, these numbers over here don't work. So let's pick a number to the right of 3. Let's pick 6. So 6 divided by negative 3 is negative 2. Negative 2 plus 2 is 0. Is 0 less than 1? Yes, that is true. 6 is to the right, so I shade to the right. So I hope that helps with any type of problems you're doing or trying to shade or coming up with those types of inequalities. Remember the important keys here. If you divide or multiply by a negative for an inequality, you must make the opposite inequality on the next step down. Okay, so I hope that helps.